Hi, I'm Miss Tarr.
Hello, I'm Mr. Bailey.
We're your math teachers this year. We're going to be doing the Cornell notes, and we're going to do scientific notation this week. So first thing you need to do is put your name, math class, period, and the date. We're doing, like I said, scientific notation. The essential question is,
Why do we need scientific notation and how do we use it?
okay, so scientific notation, we use that when we are dealing with very large and very small numbers. And we use that because we need it to keep track of the place value. And so we write in scientific notation. I can't write and talk at the same time because I can't spell. If I do that, I mess up. So we use scientific notation to help us keep track of that place value, because when we get all those numbers, it's hard to make sure we're not leaving a number out when there's a bunch of zeros involved. So scientific notation helps us do that.
Scientific notation is written as the product of a number n that is greater than 1 and also less than 10 and a power of 10. The example here, 300,000, shows a number in standard form. To the right, it shows that same number in scientific notation.
Now this number 3 times 10 to the 5th is scientific notation. Sometimes they'll show it 3 without a decimal, but they can also show it as 3.0 times 10 to the 5th. Either way would be correct. Sometimes they'll show it with the decimal, sometimes without. Just be aware of that. Now when we convert from standard notation to scientific notation, there are steps that you need to follow. The first step is to write a decimal point after the first non-zero number. So if we have the number 642,000, the thing you want to do is looking from left to right, look for the first non-zero number. Well, it would be the number 6. So we know that in a standard number that the decimal would be at the end of it right here. So what we want to do is we want to take the decimal from here and move it to after that first non-zero number, the 6. So we move it to between the 6 and the 4 to right here, which makes this number between 1 and 9.9, because 6.42 comes between 1 and 9.9. So now that we've moved that decimal from the end here and we're moving it to right here between the 6 and the 4, the second step of the process is to count the number of places needed to move that decimal point in order to get it back to the original number. So we're counting how many places we needed to move it in order to get it between the 6 and the 4. So we were counting it 1, 2, 3, 4, 5 places. So since we're moving it 5 places, we write the number of places as an exponent. This is step 3. We also can say, instead of exponent, we've also used the word power. You can use either word, exponent to 10 or power to 10, and leave out the zeros at the end. So all those zeros that were up here, you leave them out and you just write it as 6.42 times 10 to the 5th. Now you need to make a note that this number right here that we started with, 642,000, this number is bigger than 1. Whenever the number in scientific notation that you start out with, whenever it is bigger than 1, your exponent is always going to be positive. Okay, now you're going to use the same steps as 1, 2, and 3, but when working with the decimal, starting out in standard notation, that's between 0 and 1, which this decimal is. If you had a number line down here and you had 0 here and 1 here, 0.059 would be between these two numbers. So when you have a number that is between 0 and 1, your exponent will always be negative. But you do the same steps as you did right here. So what we're going to do is we're going to move this decimal to between the first non-zero number. Well, the first non-zero number here, moving left to right, is the 5. So we're going to move it to behind the 5. Okay, which they did right there. And then we're going to count how many places did you move it? 1, 2 places. Okay, and it tells us whenever this number starts out between 0 and 1, we have a negative exponent. So it is 5.9 times 10 to the negative 2, because we moved it 2 places. The power of the exponent will always match how many places you move that decimal. Okay?
All right, so now we're going to look at a couple examples. We're going to do the first 2 with you, and then we're going to allow you to do the bottom 2. So we're looking at 237, and we see that 237 is a number greater than 1. So we look back up at our notes. Because that number is bigger than 1, we know that our exponent already is going to be positive. So in this situation here, we're looking for the first number. Okay, we'll just say the first non-zero number. The first non-zero number is 2. Okay, so we need to move that decimal in between the 2 and the 3. Right now, currently, the decimal, because this is a large number, is behind the 7. Okay, and we need to move the decimal from that point in between 2 and 3. So you go over 1, 2. Okay, so you move the decimal 2 times.
So it'd be 2.
2.37 times 10, and our power is going to be 2 because we moved the decimal 2 times.